Ever seen ice building up on an engine inlet?
Yeah, that's not good.
Definitely a sign that something's not right with those anti-ice systems. You know, I was actually looking at some material for this upcoming test
Oh.
on turbine and reciprocating engines.
Uh-huh.
And some of the stuff about cooling systems really caught my eye. Like, did you know that most of the air going through the combustion section is actually used for cooling, not combustion?
Oh, yeah, absolutely. It's something like, what, a 75-25 split?
75% for cooling?
Yeah, most of it's just keeping those components from melting.
That's wild. I mean, it makes sense when you think about the amount of heat those engines generate, but I never realized it was that much.
It's incredible the amount of engineering that goes into managing all that heat.
So speaking of heat management, what about those mini tornadoes you see in front of engines sometimes when a plane is on the ground?
Oh, you mean those vortices?
Yeah, those things. Are they as bad as they look?
They can be. They can suck in debris, FOD, which can cause all sorts of damage.
So how do you prevent that?
Well, that's where vortex dissipators come in.
Vortex dissipate.
Yeah, they basically use high-velocity bleed air to break up those vortices before they can cause any trouble.
That's pretty clever. But why are they only activated on the ground? What about when you're taking off?
Ah, good question. It's all about those ground clearance and airflow patterns when the plane is, well, on the ground. Once you're in the air, the airflow changes and it becomes less of a problem. They're actually activated by the landing gear.
Oh, so they only turn on when the plane's gear is down.
Hmm.
That makes sense. So shifting gears a bit, let's talk about some of the hottest parts of a turbine engine. Any guesses?
I'd have to say somewhere in the combustion chamber, maybe the fuel nozzles.
Close. It's actually the first stage turbine nozzle guide vanes.
Oh, right, of course, because they're the first things those superheated gases hit after leaving the combustion chamber.
Exactly. So they have to be incredibly durable to withstand that kind of heat. And speaking of heat, have you ever thought about what happens when you turn on an anti-ice system? How does that affect engine performance?
Oh, well, when you activate the anti-ice, it uses bleed air from the engine, which takes away from the air going to the combustion. So it reduces engine power a little bit.
Makes sense. You're basically diverting some of that air away from creating thrust. What kind of indication would a pilot see on the instruments when the anti-ice is on?
Well, you'd see changes in the tachometer, EGT.
EGT, that's exhaust gas temperature.
Right, and EPR.
Engine pressure ratio.
Yep.
Okay, here's a little thought experiment for you. Imagine an engine is running at high speed on the ground just before takeoff. What do you think happens to the air pressure inside the inlet?
Well, you'd think the pressure would drop, right? Because the air isn't moving forward at high speed yet.
That's what I thought too.
But actually, it increases.
What? Really?
Yeah, the inlet duct is designed with a divergent shape, meaning it widens as the air flows through. And this widening actually causes a slight pressure rise.
Wow, that's counterintuitive. So even when the plane is stationary, the shape of the inlet duct is playing a crucial role in managing airflow and pressure.
Absolutely. It's all about optimizing engine performance.
Now let's talk about reciprocating engines for a bit. They have a completely different cooling system compared to turbine engines, right?
Yeah, they use a combination of air and oil cooling instead of relying primarily on internal airflow like turbine engines.
Right. And I remember those air-cooled engines with their big cooling fins. How does that whole system work?
Well, it all starts with the cowling.
The cowling.
Yeah, it's carefully designed to direct airflow over the cylinders. And there are all sorts of components like those baffles and deflectors.
I've always been fascinated by those things.
Yeah, they direct the airflow where it needs to go.
And then you've got those cowl flaps that always seem to be moving.
Oh, those cowl flaps, they regulate the amount of air flowing over the cylinders.
They open and close depending on the engine temperature, right?
Yeah, exactly. When the engine's cold, the flaps are closed to trap heat and help it warm up. And once it reaches operating temperature, they open to allow more cooling air through.
So it's all about maintaining that ideal temperature.
Right.
What about those cooling fins? Those seem pretty crucial to the whole air cooling process.
Oh, absolutely. Those fins are essential for dissipating heat, but they can be vulnerable to damage.
Oh, yeah.
I've seen fins cracked, bent, even completely broken off. Vibrations, impacts from debris, it can all take a toll on them.
Wow. So what happens if a fin gets damaged? Is it a quick fix?
It really depends on the severity of the damage and where it is. Sometimes you can repair it, but if it's bad enough, you might have to replace the entire cylinder.
Wow, those fins are a lot more important than they look.
Definitely. They might seem small, but their job is huge.
It makes you realize that every single part of the engine plays a crucial role. Speaking of which, we've got to talk about those temperature monitoring systems. They're like our eyes inside the engine, Ray.
Absolutely. They give us that real-time data we need to keep those engines running smoothly.
So for reciprocating engines, you've got the bayonet and gasket type probes for the cylinder heads, right? What's the difference?
The bayonet type, well, it's just like it sounds. It uses a bayonet fitting to attach to the cylinder head.
So kind of like what you see on a rifle.
Yeah. It makes it quick and easy to install and remove.
And the gasket type.
That one uses a threaded fitting and a gasket to make a nice, tight seal.
So each type has its own advantages and disadvantages.
Right. It often comes down to the specific engine and what the manufacturer recommends.
Now, how do those probes actually work?
Yeah.
How do they measure the temperature?
They use something called a thermocouple.
Ah, yes. Thermocouples.
Basically, it's a sensor that creates a voltage based on the temperature difference between two different metals.
So one part of the thermocouple is touching the hot cylinder head, and the other is at a known cooler temperature.
Exactly. By measuring the voltage between those 2 points, you can determine the temperature of the cylinder head.
That's pretty ingenious. I never realized how much science and physics goes into something as seemingly simple as a temperature gauge.
It's amazing, isn't it? Just goes to show how much thought and engineering goes into keeping these engines running cool and efficiently.
This has been really eye-opening. We've covered so much ground today, and it's given me a whole new appreciation for these cooling systems.
Me too. There's still so much to explore, though.
I know. I'm already looking forward to diving back into this next time.
Sounds good to me. Ready to keep talking about engines.
Absolutely. I was just thinking about those engine insulation blankets, those things that protect the surrounding aircraft structure.
Yeah. Those blankets are crucial. They prevent heat damage to all those important parts and make sure the whole aircraft structure stays intact.
It's like they're a shield against the heat.
Exactly. A thermal barrier.
And speaking of protection, I was thinking about those cylinder fins and how vulnerable they are to damage.
They can get cracked and bent, even broken off. Oh, yeah. And you know what? It could be something as simple as a pebble during taxiing.
I guess you really have to be careful during those inspections.
Those inspections are so important. You got to catch any little problem before it becomes a big one.
So if you do find a damaged fin, is that an easy fix?
Well, it all depends. How bad is the damage and where is it? Sometimes you can repair it, but other times.
You have to replace the whole cylinder.
Yeah, sometimes.
Wow, it's amazing how such a small part can make such a big difference.
Oh, yeah. They're tiny but mighty.
So we were talking about temperature monitoring systems before. Those probes are so cool, they give us a look inside the engine while it's running.
It's like having a window into that hot zone. And the technology has gotten so advanced, it gives you real-time data on engine temperatures. It's incredible.
But what happens if one of those probes gives a bad reading? How do you know what to trust?
That's where the pilot's training and good maintenance come in. Pilots are trained to recognize when something's off, abnormal readings, and we test and calibrate the probes all the time.
So you've got a system of checks and balances to ensure the data is accurate.
Right. The technology's great, but you still need that human element.
That makes sense. Speaking of human elements, you were talking about how reciprocating engines use a lot of air cooling. Can you walk me through that system again?
Sure. So it all starts with the cowling, which is like a channel, guiding the airflow over the engine cylinders.
Okay.
And those baffles and deflectors are strategically placed. It's like a carefully designed path, directing the air exactly where it needs to go.
And then there are the cowl flaps. Why are they always moving?
Those cowl flaps regulate the amount of air going over the cylinders. When the engine's cold, they're closed to help it warm up. But once the engine is warm enough, they open up and let that cooling air through.
So it's all about finding that balance, keeping the engine at the right temperature?
Exactly.
It's like you're breathing.
Yeah.
But isn't it more than just the quantity of air? It's also about the direction and speed, right?
Oh, absolutely. Those baffles and deflectors, they actually create kind of a high pressure zone around the cylinders.
And that forces the air to go through the cooling fins.
Yep, you got it. It's all about that airflow.
So you've got air cooling, but what about the oil cooling you mentioned earlier?
Yes, the oil. So the engine oil actually absorbs a lot of heat from the internal components. Think of it like the cooling system in a computer.
So the oil circulates through the engine, picks up the heat, and then carries it away to be cooled down.
Exactly. You got it.
It's like a tag team, the air and oil working together.
It really is. It's a constant process of managing the heat, ensuring those engines stay healthy.
It's a pretty impressive system. And it shows you how important regular maintenance is.
Oh, absolutely. Maintenance is key. These are complex systems, and if you neglect them, you're asking for trouble.
Speaking of complex, let's go back to turbine engines for a minute. We talked about those accessory zones with their generators and pumps.
Yeah.
They need their own cooling systems, right?
You bet. And it's not just about keeping those components from overheating, but also preventing fires. Remember, we're using bleed air for cooling, so it's hot.
Right. That bleed air is under a lot of pressure. What happens if there's a leak?
That's when things can get a little hairy. A leak can lead to pressure loss, which affects engine performance. And if you have flammable vapors from fuel or oil and that leaking air ignites,
A fire.
yeah, not good. But they've thought of that and designed something called a pre-cooler. It's like a heat exchanger, and it cools down the bleed air before it enters the accessory zone.
So the pre-cooler is like a safety net.
Exactly. It condenses those flammable vapors and reduces the risk of fire.
That's a really clever solution.
Yeah.
So much thought goes into every little detail. Speaking of which, let's talk about the cylinder head temperature gauge. It's really important for monitoring reciprocating engines.
Right. It gives you a direct reading of the cylinder head temperature, which is super important.
So what does it tell you exactly?
Well, it tells you how hot the cylinder head is, which, as you know, is the hottest part of a reciprocating engine.
Sure.
And it helps the pilot monitor the engine's performance, helps prevent damage, and gives them information for adjusting the engine operation.
Almost like a warning system.
Yeah, pretty much. Like,
Yeah.
if the temperature is creeping up, the pilot knows there might be a problem. It could be a blocked baffle or a bad cowl flap.
So it's a way to catch problems early.
Exactly. Because if the temperature goes too high, you could have detonation or even engine failure. Not good.
So are there different kinds of cylinder head temperature gauges?
Yes, there are. You've got the bayonet type and the gasket type.
What's the difference between those two?
The bayonet type is just like it sounds. It's a bayonet fitting, like on a rifle, to connect to the cylinder head.
Yeah.
Easy to install and remove.
Okay, so what about the gasket type?
The gasket type uses threads and a gasket for a more secure, leak-proof connection.
So each type has its own advantages.
Right, and it really just comes down to what the engine manufacturer recommends.
Got it. Now, how do those probes actually measure the temperature?
They both typically use a thermocouple to sense the temperature.
The thermocouple?
It's basically a sensor that generates a voltage based on the temperature difference between two junctions of different metals.
Oh, okay. I remember now.
Yep. So you have one junction at the hot cylinder head and the other at a known cooler temperature.
Right. So the voltage tells you how hot it is. It's a pretty elegant solution.
It really is. These engineers are smart cookies. They've harnessed these principles to create tools that we rely on for safe flights.
It's amazing how such a small component can be so important.
Absolutely. It's all connected.
This has been a really fascinating conversation. We've covered so much today, from those little fins to those sophisticated temperature gauges. It's really given me a new perspective on these engine cooling systems.
Me too. And we're not done yet. There's still more to explore.
I know. This stuff is really interesting.
It is.
So those cylinder head temperature gauges use thermocouples, right?
Yep. They're pretty neat, huh?
Yeah. I mean, it's amazing how they can turn heat into electricity.
Like little mini power plants.
Aha. That's one way to put it.
But they're vital for making sure we know what's going on inside the engine.
Absolutely.
Yeah.
So we've talked about how to measure the temperature of reciprocating engines, but what about turbine engines? How do you check the exhaust gas temperature on those?
Ah, good question. For turbine engines, we use something called an EGT probe,
EGT.
exhaust gas temperature.
Right. And where's that located?
Usually in the exhaust stack, right after the turbine section. That's where the gases are the hottest,
Makes sense. So the EGT reading, it's kind of like the cylinder head temperature for a turbine engine.
Exactly. It tells you how the engine's performing and helps catch any potential problems. Like, let's say the EGT suddenly spikes. That could mean there's something wrong with the fuel-air mixture or maybe a problem in the combustion chamber.
So whether it's a reciprocating engine or a turbine engine, those temperature probes are super important for keeping things running smoothly.
For sure. They give us a window into what's happening in those hot zones.
Now let's talk about those turbine engine insulation blankets again. We were talking before about how they protect the surrounding aircraft structure from all that heat.
Oh, yeah. Those blankets are essential. They act like a shield, keeping everything safe from those high temperatures.
And they're made up of layers of fiberglass, aluminum foil, sometimes even silver, right?
You got it.
But it's not just the materials, right? I bet the way they're installed is pretty important, too.
Oh, absolutely. They have to be fitted perfectly and secured really tight to the engine and structure.
I can imagine even a small gap would be a problem.
Yeah, even a little gap could let hot air escape, and that could damage nearby components. It could even create a fire hazard.
So those blankets, they're not just protecting the aircraft, but also preventing fires.
Yep, that's right. It's all about safety.
And speaking of safety, we were discussing those pre-coolers earlier, those things that cool the bleed air before it enters the accessory zones.
Right, right. The pre-coolers are key for preventing those flammable vapors from igniting. Just another layer of safety.
It's incredible how much thought goes into every little detail. They really think of everything, don't they?
Absolutely. Safety and performance go hand in hand. One can't exist without the other.
Well said. Well, I think we've covered just about everything today. We've talked about so many different aspects of engine air and cooling systems, both for turbine and reciprocating engines. I've definitely learned a lot, and it's given me a much deeper understanding of how these systems work.
Me too. It's been a great conversation.
Absolutely. It's been great talking about all these different components, from those tiny little cylinder fins to those sophisticated temperature gauges, and how they all work together to keep those engines running cool and reliably.
It really makes you appreciate the complexity of these systems and the amount of engineering that goes into them.
Yeah. It's amazing. Well, until next time.
Keep those engines cool.